Hey guys, so came up with a really nice IK algorithm last night, and what I mean by really nice is that it supports multiple end-effectors, but it's also really stable under constraints. So what you see is right now the joints kind of curve out as they bend inward. The reason they're doing that is because they're satisfying constraints. So that green thing there, that's just a constraint saying that this joint can't go past that green disk. And this is all very stable even with multiple end effectors, and every single joint in this chain is constrained. I'm going to write up how the algorithm works hopefully tonight because I really like it, and I'll be releasing the source. But I've just been having a lot of fun playing with it. The algorithm is kind of a weird marriage between Fabric and CCD, but it does seem to be more stable than CCD, much more stable than Fabric, but it still supports multiple end effectors like Fabric does. In this chain, pretty much every bone is constrained, and I can modify the constraints to be more severe if I want. So let's see. I can make this guy really tightly constrained. Oh, by the way, right now you're seeing this all happen. This is every frame is just one iteration of the algorithm, so it also ends up converging really quickly. And again, it does this through multiple end effectors and with almost every bone in the chain being constrained. Someone asked if it was parallelizable. It sort of. I mean, if you're using multiple end effectors, yes. Otherwise, each bone is kind of dependent on the bone ahead of it. Its orientation is dependent on the bone ahead of it. So you can't really get around the fact that you need to do some things in sequence. But anyway, I'll be posting a tutorial soon if anyone wants to implement it for their own purposes, and I'll be posting a processing library of it or a Java library if people want to use it in their robotics projects or animation projects or whatever. Alright, that's it for this sort of update kind of thing. Eloquence, yeah!